Welcome to Train Signal. You're watching a lesson on configuring and troubleshooting DNS. Now, real quick before we get started, because I will tell you that this is going to be a bit of a doozy of a lesson. When it comes to DNS, there's a lot to know. But if you happen to have watched my DNS lesson in the Windows Server 2012 installing and configuring course, okay, the 70-410 course, most of the information is pretty much the same as what we're going to go over here. I'm just going to go ahead and hopefully help solidify it and then make sure that we fully understand how to truly get in and administrate it at this point. Okay, so I just wanted to kind of give you that heads up. If you're having a little deja vu moment, if you watched that other course and now you're watching this one, yeah, it's not you. This actually is a deja vu moment. We've actually repeated a lot of this information. It appears in both the 70-410 and 411 exams, so I need to do this. So real quick, just to review, let's make sure we know exactly what DNS is. Okay? DNS stands for the Domain Name System. And to just real quick and easy, just kind of simplify what it's all about, DNS is used to translate domain names into IP addresses. Or as I like to put it, and again, if you've watched any of my courses, you know I say this all the time, it's DNS that allows us, and I'm including myself in that us, so don't be offended by this, but allows us to be stupid humans. Now, what do I mean by stupid humans? What I mean is, when I want to go to my favorite website, I, as a stupid human, I'm able to remember it by its name, but I can't seem to remember it by its IP address. Right? I mean, think of your favorite website, right? And I know what your most favorite website is, and that is trainsignal.com, right? But do you know the IP address of trainsignal.com? Because I'll tell you what, I work here and I don't even know what it is. Okay, so as a stupid human, we like to think of things with simple names, and then the computer wants to actually communicate between these different systems using IP addresses. And it's DNS that will do that conversion for us. Now, there are three main components to a DNS system, right? The entire DNS system is made up of DNS servers, and the servers contain the component number 2 here, DNS database of names to IP address mappings. Okay, so that's what the servers do. They hold this database of names and their matching IP addresses. And then, of course, we have DNS clients, which, as we know, just kind of as a whole, servers serve resources and clients access resources. So it's the clients who will then, in this case, we call it query the server. So when I say I want to go to trainsignal.com, I need to query a DNS server and say, I want to go to trainsignal.com. And that's all I know is the name. I don't care about the IP address. But my computer does, right? The client computer does. So it queries the server and says, what's that IP address for trainsignal.com? And then it's given that IP address so that it can truly go out there and communicate across the network. Now, I will also tell you, and we'll see this later on in the lesson, that the DNS database actually contains more than just that most basic type of record that I mentioned, where we just have names and the matching IP addresses. There are other types of records, as they're called, that are inside of this database, and we'll visit those before we're done with this lesson. Now let's talk about these names for just a minute. Okay, we have to understand what a domain namespace is, and we need to understand that it's a hierarchical type name. Okay, it's got a structure to it. And when we talk about trainsignal.com, did you know that technically the full name is trainsignal.com dot. There's actually a dot at the end. And when we're figuring out that actual namespace, we look at it, or at least the system looks at it, actually reading from right to left. So even though in the English language we read it from left to right, I say trainsignal.com, the network is looking at it as the dot, that imaginary dot that's at the end of the com. Then it looks at the com. Then it looks at another dot that separates into the next domain, which would be train signal. So another example that I have here on the screen for you is if we start off with that first dot, that's what's called the root domain. And when we get into looking at the actual DNS server, and we'll go into Windows Server 2012 here in a minute, and we'll look at this. There's actually something called root hints. And the root hints are the IP addresses of the DNS servers out on the internet that represent and are authoritative for the root domain, which is that dot. And it's that invisible dot that we don't actually type in. But then we have our top level domains. Right? We have our .nets, our .coms, our .orgs. I mean, there's a whole list of them. There's one for every country, and the list goes up and up every year. But those are our top level domains. And so what the root DNS servers are going to do is they're going to be responsible for knowing about the top level domains. Those top level domains will also have their own DNS servers who will be aware of what's called the second level domains. And so the example I have here would be Globomantics, okay, or in the example I was giving you a moment ago where I say trainsignal.com, TrainSignal is the second level domain. Now from there you can have further subdomains that go even beyond that. Okay, so in the case of the illustration here on the screen, we could say HQ being a subdomain of the Globomantics.com domain. And as a matter of fact, we can even go another subdomain deeper than that if we wanted to and say that we have the sales.hq.globomantics.com domain. And at each level, again, remember, that domain level will have DNS servers that are what's called authoritative for that namespace. And it will know about anything that's inside of it, any subdomains, any subdomains going down through the hierarchy. And then from there, you'll notice that in that sales domain, there is a host, there's an actual computer there, whose name is Server A. Now, Server A's fully qualified domain name, using the example here, okay, so FQDN, would be servera.sales.hq.globomantics.com. And then again, although I don't have it printed there and we don't ever type it in, there is one more dot at the end of that com. Okay, it's an invisible one that the network looks at. So that's how namespaces work. Now I mentioned clients querying servers, right? And the query, the idea behind the query is it's a request for name resolution directed out at that DNS server. Right? In other words, if I, the stupid human, am sitting at my computer and I say, I type into my browser, I want to go to trainsignal.com, my computer as a client will go to its DNS server and do this query. It'll say, hey, I need an IP address for trainsignal.com. Now there's two different types of queries. There's a query called iterative. And I'll tell you what, I've heard that word pronounced many different ways. Iterative, iterative, pronounce it how you want. You can see how it's spelled. And what an iterative query is it's the type of query where the DNS server is responsible for responding with whatever it knows. But that's it. Even if that answer is nothing more than maybe a referral to another DNS server to go ask. Okay, so an iterative query, if that's the type of query that a DNS server gets, it'll look in its database and it'll tell whatever it knows. If it knows the answer, it'll give the answer. If it doesn't know the answer, it won't give the answer. If it doesn't know the answer but says, hey, there might be somebody else you can ask, then it might give that. That's an iterative query. A recursive query is where the DNS server will actually go out and find the answer on your behalf. So if a recursive query comes into a DNS server and the DNS server looks at its database and goes, I don't know what the IP address is that they're looking for, then it will go out there and it will make additional queries on the client's behalf until it comes up with an answer, whether that answer is the IP address or maybe what's called an authoritative no, or an authoritative doesn't exist. Now that word authoritative, I've used it a few times. And DNS servers can be authoritative or non-authoritative over a certain DNS namespace, or what we'll also see are sometimes called zones. Okay, they're kind of the same. They have different versions of what they mean as far as namespace, just literally lining out an area of namespace, whereas the zone is an area of that namespace that a DNS server can be authoritative over. And as I mentioned a moment ago, it's an authoritative server who can give the answer or what's called an authoritative no. Okay, so I know that reads a little funny there. It gives either the answer that you're looking for, right? It says I'm authoritative and hey, I have the actual IP address you're looking for. Or it can say no, you know what? That computer doesn't exist. That's an authoritative no. A non-authoritative server is one that when it gets requests, it can either be what's called a caching-only DNS server, and we'll talk about caching in a moment, but it's the type of DNS server that doesn't have a database at all. What it does is it goes out there and does additional queries on the client's behalf, and then it stores what it finds in its memory or in its cache. Okay, but that server itself is not authoritative over any particular DNS namespace or zone. Or we could also have a DNS server that is not authoritative for any particular namespace, and it is used as a forwarder, which we'll learn about forwarders also in just a little bit. Did I mention, by the way, that there's a lot to learn here when it comes to DNS? Right? I said this lesson was going to be a doozy. Can you tell? Everything I'm talking about, it leads to something we're about to get to. And it'll only be when we get to the end of the lesson that I can say, all right, well, now we've gotten to it all. So let's talk about how these queries work. Here's an example of a client making what's called a recursive query for www.globalmantics.com to its local DNS server. Right? So picture your environment. You're sitting at a computer. That computer will then go out to some DNS server that's on your network and say, hey, I'm looking for www.globalmantics.com. And this is what's called a recursive query, which means the local DNS server, if it doesn't know the answer, it'll go out and find the answer on the behalf of the client. Now, the DNS server, in this case, the local DNS server, does not know the answer. So what it's going to do is it's going to do what's called an iterative query out to one of the root DNS servers out on the internet. Right? I mentioned those root hints and those root DNS servers. So it's going to go ahead and say, hey, root DNS server, do you know who www.globalmantics.com is? And the root DNS server is going to say, no, I don't know, right? Because in an iterative query, it's just going to give an answer of what it knows or does not know. It's going to say, no, I don't know. But I see that in your hierarchical DNS name there, you have a .com at the end. And I do happen to be aware of a DNS server that is authoritative for the .com domain. So why don't you go, here's the IP address for that DNS server. Go ask that server for the IP address that you're looking for. At this point, the local DNS server, since it still doesn't have an answer, it'll do just that. It'll go make another iterative query to that .com DNS server and say, hey, do you know who www.globalmantics.com is? And that .com server will say, nope, I don't know. But what I do have registered in my database is the IP address for a DNS server that's authoritative for globalmantics.com, which I see is in the name of what you're asking for. So why don't you go ask that server? So the local DNS server, once again, not having a complete answer yet, and also does not have an authoritative no, it says, all right, I'll go make another iterative query to the globalmantics.com DNS server and say, hey, do you know who www.globalmantics.com is? And that server says, well, why, yes, I do. I do know the IP address for www.globalmantics.com. Or, because that particular DNS server is authoritative for globalmantics.com, it could give an authoritative no, that name doesn't exist. Either one of those are acceptable answers. And at this point, the local DNS server has the answer. In this case, it was an IP address. So it sends the IP address back down to the client. So when you open up your internet browser and you type in your favorite website, guess what? Everything I just illustrated here happens every single time. And by the way, it's not necessarily every single time, and we will look at that as well before we're done with this lesson. Forwarder is another term that I just mentioned a few minutes ago. So let's talk about what this is. Forwarder. Forwarder is a DNS server to which other DNS servers forward queries. Hey, that kind of makes sense, right? Right? If I get a query and it's for something that I'm not aware of, I will go ahead and forward that request onto another DNS server. Now there are two different types of forwarders. We have standard forwarding, which is the type of forwarding we've had pretty much since day one when it came to DNS. And then we have conditional forwarding, which is a little bit newer. It's not new to Windows Server 2012, but we didn't always have it. And conditional forwarding is where we pick a specific namespace, and based upon that namespace, we forward it to a specific DNS server. Okay, so we can have a DNS server, believe it or not, set up in our network that maybe is not authoritative for anything, and its sole purpose is to redirect onto other DNS servers based upon what namespace you're trying to look up. And that's how conditional forwarding will look. So let's see how the whole idea of this works. Here we have a client who, once again, is making its recursive query to a local DNS server. Now, the local DNS server does not know the IP address for www.globalmantics.com, but it has been set up with forwarding. Okay, it's been configured to say, if you don't know the answer, here's who I want you to go ask. So it goes ahead and it does a recursive query out to the forwarded DNS server, or not the forwarded, but the forward DNS server, the DNS server it's been told to point to. That DNS server will then do all the iterative queries out with the root hints and the .com server and the globalmantics.com server. It'll get the answer on the behalf of the local DNS server, send the answer back to that local DNS server who was doing all this on behalf of the client, so it sends it back to the client. Now that's how regular forwarding works. What about conditional forwarding? With conditional forwarding, we could have an example here where a client makes a query for www.globalmantics.com, and the local DNS server might be set up with a conditional forward that says, hey, if anybody's looking for anything that includes globalmantics.com, let's go ahead and put in the specific IP address of the globalmantics.com DNS server, and let's forward that request onto it. And if I get a request for anybody else, we'll go out to root hints. So let's go ahead and jump over to our Windows Server 2012 operating system, and well, let's see how exactly this forwarding is configured. Okay, so here we are on a Windows Server 2012 computer, and I will tell you going in that, well, there's a couple things. Number one, this computer is NYDC1. This is a domain controller in our globalmantics.local domain that has been set up as part of this course. I've been using it throughout the course. And the other significance to this particular server is that it already has DNS installed. All right, so DNS has been installed as part of the Active Directory installation, and we'll talk about something called Active Directory Integrated Zones, a little bit about how DNS can get installed with Active Directory, and that's what's been done on this server. If you ever had a server that did not have DNS installed and you wanted to go ahead and install it manually, well, the way you would do it is through the server manager, and the reason why is because it's a role. Okay, so just like any other role, you'll notice, by the way, we already have the DNS role installed. But if I click on Add Roles and Features, it takes me into the Add Roles and Features wizard. It's a role-based installation. Next. Where do I want to install it? Next. And then right here, now it's grayed out and it's already checked because, well, it's already installed. But all you would do is you would check the box, and that's how you install the DNS server role on a server. And for more detail on that, you can always go back to the Installing and Configuring course, right, the 70-410 course for that. But in the meantime, what we want to do here, we already have DNS installed, is I'm going to go ahead and click my Start button here to get to the Start menu, and here I'll see DNS, so this takes me to the DNS utility. Now again, it's already installed and already have some things configured here, and that's because it was done as part of the Active Directory installation. And we're not going to worry about that so much. I just want to show you forwarding. And I want to show you that if I go to my server here and right click and go to its properties, you'll see that there's a forwarders tab. And this is where we can go ahead and specifically set up a forwarder that we want to go ahead and send any unresolved queries to. Now, in this particular instance, I will tell you that this IP address has been thrown in here because in my local office environment, so this is not something you necessarily want to copy if you're following along. In my local office environment, I am operating the 192.168.10 network. And I will also tell you that outside of this lab that I'm using for the course, I do have a DNS server here in-house, and the IP address is 192.168.10.1. So this system has been set up to say if I don't know the answer, then go ahead and let's go to that other DNS server that I know has been put in place to handle other queries around the office. Okay, so that's just a generic forwarder. Now you'll also notice that there's a checkbox here that says use root hints if no forwarders are available. Okay, and sure enough, there's a root hints tab here, and I promised you I would show you this. And here are the IP addresses of the root DNS servers out on the internet. Okay, so those are the IP addresses that we're going to go out and query if we get a generic internet-based request if there's no forwarders available. So that's just standard forwarding. But what we also have is we have conditional forwarding. Right? We have our conditional forwarders here, and if I right-click and select New Conditional Forwarder, well, this is where I could put in a specific domain. This is where I could choose to say, hey, you know what? If somebody is specifically looking for trainsignal.com, let's go ahead and send them to a specific IP address. Now I don't have one to do here, so I'm typing in a hypothetical here. Okay, but the idea is I put in a specific name and then I put in an IP address to, and I apologize, it's kind of shifting around because as soon as I clicked away, it's trying to resolve and validate that that particular DNS server is authoritative for that namespace, and as you can see, it's erroring out because this is a hypothetical. I don't actually have this set up here. But that's all I would need to do. And I can click OK, and now you'll see that I have this conditional forwarder for trainsignal.com. So any requests that come to me, and me being this DNS server, and I don't know what to do with them, send them to this other DNS server if it's specifically for trainsignal.com. So let me go ahead and delete that real quick because I don't want to cause any problems on my system here. But that is how forwarding and conditional forwarding work. Now, another thing that I want to talk to you about, I mentioned this earlier, is something called caching. And the idea is that if a DNS server is going to go out and do research on the behalf of a client, then maybe instead of just giving the response to the client, maybe I should also keep that in my memory so that if that same client or even another client makes the same request, I don't have to go out to the root DNS servers and go through that whole iterative querying process. I already know the answer. Okay, so that's the idea behind caching. And there is also something here called a caching only server, which would mean that I'm a server that doesn't have any, I've installed the DNS server role, but I haven't set up any zones, right? I'm not authoritative for anything. But if clients are looking to me, well, then I'll go ahead and I will do these iterative queries, find the answer, store the answer in my memory so that if anyone else asks for the same thing, I can give them that answer. And if I don't have it in my memory, well, then I go out there and I do the iterative queries, and then I put it in my memory. So you need to keep in mind that a cache is something that, not only do servers have, but clients have as well. Okay, so a client also, when it makes a request to a DNS server, when it gets the answer, it stores that answer in its own memory as well. But there's a problem with this, and that is that sometimes the stuff that's in memory might get to be out of date. Now, this can be solved with something called time to live, which is a specified amount of time that's on a record, that information is allowed to be stored. But either way, it can still sometimes become an out-of-date piece of information, and so you may need to clear the cache. And there are actually there's actually 3 ways. I only listed 2. I should have put a third way, because in Windows Server 2012 we always have this third option. When it comes to clearing the DNS server cache, you can either use the DNS console, right? I mean, the actual GUI, the actual console. You can right-click on the server and ask it to clear its cache. You can use the command line, which is something called DNS command. And then you also have PowerShell. Okay, that is the one other option that is also available always in Windows Server 2012. We always have the ability to pretty much manage anything using PowerShell. So that really is the third option. And by the way, the command, the PowerShell command, it's fairly intuitive. It's actually clear -DNS client cache. Okay, so anyway, that's how you would clear the server cache. The client cache, however, you would clear using the ipconfig command. Now, you may know the ipconfig command as being that thing that allows you to see what the IP address is for a given computer. Well, believe it or not, that command has more capability than just that. Now, it actually has more ability than just looking at the IP address, and one of those abilities is to clear the DNS cache for that client. So let's look real quick at how caching works here. Client makes a request to the local DNS server. Local DNS server goes out there and does all its iterative queries, and it gets authoritative response. Now, we've seen this screen before, and the next thing that I showed you last time we looked at this, when we looked at querying, is that the server sent that response back to the client. But here's what actually happens. First, the DNS server stores that information in its local cache. Then it passes it on to the client. And the reason it does that is because when a second client comes in asking for the same information, that local DNS server can just simply go to its cache and go, I already know the answer. I don't have to do all that crazy querying. And then I can send that back to the client. Much faster, uses up less internet bandwidth, and that's why we use caching. Now, here's another term that I've been using that I promised we would get to, and that is the term zone. Okay, so what is a DNS zone? As I mentioned earlier, a zone is an area of DNS namespace, right? We talked about namespace earlier, but in this case, it's an actual entity on the server itself that makes it that DNS server is authoritative over that namespace. So in the illustration that I have here, I have a whole DNS hierarchy that's been built out, and you'll see here that we could have a zone that says support.na.globalmantics.com. That's one area of namespace, and there could be a DNS server that is authoritative over that namespace by having a zone called support.na.globalmantics.com. Another example over on the right is where you see that we have Asia.globalmantics.com, and then we also have sales.globalmantics.com. And there's 2 different ways of looking at it. Some people can say that you can make one zone that says that you're authoritative for both of those areas of namespace. Some will argue that it's actually 2 different zones. Okay, but I just want to give you the idea, no matter how you want to look at it, that one server could be authoritative over both of those areas of namespace. Now, there are many different zone types. The traditional types of zones are what's called primary and secondary. And a primary zone is your master read-write copy of the zone. Okay, in other words, in that zone is where your database is going to be of your names and IP addresses. So if you are a DNS server that is hosting a primary zone, that means that you can actually make changes. But then you also could be a DNS server that it has a secondary zone, and that means that it's a read-only copy of the database. What that means is that you're there to respond to client requests, but you can't actually make any changes to the database. You just have a read-only copy to go ahead and respond to those queries. Now, these last two types that I have listed here, stub zones and then Active Directory integrated, they're a little bit more complicated. So let me share a little bit more detail with you. First of all, we have stub zones, and this is one of the most complicated types of zones to most people. In DNS, we have something called delegations, and where this is most typically used is with subdomains. Okay, so the idea of a delegation is where you have the parent DNS server that will go ahead and have a delegation that points to another DNS server that has authority over the subdomain. So the example I would give you is, if I'm a DNS server for globalmantics.com, I have a subdomain of na.globalmantics.com. I may have a delegation that points to the DNS server that's going to be authoritative for that subdomain, na.globalmantics.com. But the problem is, before we had stub zones, this all had to be managed manually. And what that means is, as I added additional DNS servers to the na.globalmantics.com subdomain, the parent DNS server for globalmantics.com didn't know. Okay, that DNS server did not know that these new DNS servers existed unless you manually created another delegation. So what a stub zone will do is it allows for the automatic propagation of those delegations to the DNS servers. So what you do is you create the stub zone on the parent. So on globalmantics.com, you create a stub zone for na.globalmantics.com. You point that stub zone to one DNS server that is authoritative for that subdomain. And then when new servers are added for that subdomain, the one server that the parent was already pointing to in that stub zone, it will then relay that new information back up to the parent and say, hey, there's some more delegations here. There's more DNS servers that have been added to this subdomain. So this all happens automatically. Now, the last type of zone that I want to talk to you about is actually one of the most typically, and not only just typically, but most recommended used zones in today's world of Microsoft networking, and that is the Active Directory integrated zone. And the idea behind the Active Directory integrated zone is that instead of the zone database file, because that's exactly what it is, it's a file sitting out on a DNS server, okay, with our standard primaries and secondaries, it's that database of names and IP addresses, it's a file, and it's kept on that server. Well, now, instead of a file, it's an Active Directory object. And some of the benefits that come along with that is that, first of all, we have what's called multi-master replication. So instead of having one primary and then everyone else has to be a secondary, right? You have one master read-write copy and the rest are all just read-only copies. We now have multi-master. We can have multiple DNS servers that all have the ability to not just respond to queries, but can update the database as well. And the reason this can happen is because Active Directory, the way it's designed, has a multi-master replication topology. It also allows us to streamline data replication. Instead of having to have any updates that are made to the zone database have to be replicated individually out to all the other secondary DNS servers, well, now replication just takes place as part of Active Directory replication, which is already taking place. So there's another benefit there. We also have something called secure dynamic updates. Now, we haven't talked about dynamic updates, so yet again, here's something that is, it's a term being thrown out that I'll say we'll talk about in just a minute here. But the idea of dynamic updates is that in the old days, we used to have to manually type in the names and IP addresses into a DNS server. Now, that information can be updated automatically, but that can also be a security hazard, and there are a lot of DNS attacks revolving the, going to a DNS server and saying, hey, I have an update for you. Well, with Active Directory integrated zones, we only allow what's called secure dynamic updates, which means updates can only come from computers that are known within the Active Directory database. And the one final thing that's really cool about Active Directory integrated zones is that they are backward compatible to secondary zones. So if you have any older DNS servers or maybe non-Microsoft DNS servers and you want to keep them in play, well, then you can do so by making them a secondary DNS server pointing to one of your Active Directory integrated DNS servers as your primary. And yes, it is recommended by today's standards, and this is part of why I didn't want to really spend any time on installing DNS. It's recommended that DNS should be Active Directory integrated, and it will be that way by default if you simply tell your domain controllers when you're installing them that you want them to be DNS servers as well. So it'll automatically create the zones, it'll automatically make them Active Directory integrated, and you don't have to do much. Now, there's also something called lookups, right? We talked about queries before, right? Where you go ahead and you're looking for www.globalmantics.com, and so you go ahead and you do a query out to a DNS server. Well, that example I just gave you is something what's called a forward lookup. That's where I give you the name, I need to know the IP address. But there's also something called a reverse lookup. And this is where the IP address is given to the DNS server, and then the DNS server in turn produces the name. Now, this is not as widely used, and in many scenarios it's just not even needed. And usually where you do need something like this, because again, remember, we're stupid humans. We're not going to give an IP address and then for some reason have the DNS server have to throw back the name. It's usually used to meet a specific need of a particular application. Certain applications, depending on what they're doing, may have an IP address that they need to then reverse engineer back to what is the name. Now here's dynamic updates that I said we would come back to, and didn't have to wait very long this time. Before dynamic updates, real simple, we had to type things in manually. If we had any new computers that came into our network, we had to walk over to that DNS server. And of course, back then we only had the one primary and the rest were all read-only secondary. So you'd go to the one, you had to make sure you go to the right one. You had to go to the primary, and you literally had to go in and type in a new record. Well, now this can be done dynamically from the client. So a client can actually go to a DNS server and say, hey, I just want to let you know I'm here. This is my name. This is my IP address. Go ahead and make a record of it. But as I mentioned a moment ago, that can be a problem because it's a great way for some kind of an attacker, especially like malware or something like that, to get into your DNS server and make these changes so that when somebody puts in www.globalmantics.com, because that's maybe a real popular company that they know people go to all the time, instead it redirects them out to, it gives the IP address for their website instead. So what we want to do is we want to use secure dynamic update, and this can be done by using Active Directory integrated zones. Now we also have the ability to integrate dynamic updates so that not just clients update the DNS server, but other networking services can do it on their behalf. The example one of the most popular examples, one of the most common examples would be DHCP. Okay, so DHCP has the ability, when it hands out an IP address to a client, it can then in turn, on the client's behalf, go to the DNS server and say, hey, DNS server, hi, Mr. DHCP server over here, and I just wanted to let you know I just gave out this IP address to that computer over there named such and such. Why don't you make a note of it in your database, and you'll be good to go. All right, so that's how dynamic updates works. Now I mentioned to you earlier that there are a number of different types of records in the DNS database. Right? In other words, we have more than just our very basic, stupid human named IP address records. Which, by the way, those records that I mentioned, the stupid human ones, they're right at the top of the list that I have here. Those are what's known as A records, or what's also sometimes known as host records. Those are your forward lookup records to where you just say, here's the name, if anyone's looking for it, this is the IP address. And then we also have another type of record, which is the PTR record, or pointer record, and that's the reverse lookup record. That's the type of record that if somebody comes in with an IP address and needs the name, it can be done that way. But we have a whole slew of other types of records. I have some of them listed for you here. Okay, we have SOA, which stands for Start of Authority. Has to do with replication. We have SRV, which are Service Locator records. These are very important records that, to take it even one step further, these are the records that allow Active Directory domain services to function on your network. When the user goes to log on, that client computer is going to go and say, hey, in order for me to log on, I need a domain controller, right? I need to authenticate this user. So it's going to go to the DNS server and say, I'm looking for a domain controller. Do you know about any? And that's what the SRV resource record is all about, is saying, yeah, actually I do have domain controller service resource records here saying that NYDC1 is a domain controller for that domain. And then that name will then be sent over to see if there's a matching A record, right, a host record, to go ahead and say, and here's the IP address. So go to that computer with that IP address and you can authenticate that client. And we also have NS records, which stand for name server records. These are the records that point to other DNS servers that are also authoritative for the zone. Or, as I mentioned earlier, in the stub zones, we have our NS records to point for those delegations for DNS servers that are authoritative for the subdomains. We have MX records, which are mail exchanger records, and they have, just as it would sound like, they have everything to do with email. If you're looking to send an email to such and such at globalmantics.com, DNS server will say, here's a mail server that can go ahead and service that. And then we also have something called the CNAME, or what stands for canonical name, or what's also sometimes known as an alias. And the best example I can give you of an alias is if you've ever gone to your favorite website and you've typed in www.trainsignal.com, for instance, or www.microsoft.com, or www.google.com. Do you think every single company out there has an actual web server whose name is www? Because what I can tell you is that most don't. Most companies will have a web server that will have a name like Web Server 1, Web Server 2, Web Server 3. And it doesn't necessarily have to be that name, but that's just an example. That's the actual name of the server. But because www took on such popularity back when the internet first came into creation, right? Everyone was going to the World Wide Web, and when they'd go to a website, they'd go to www.whatever. Well, we now create these aliases. So basically, here at Train Signal, I'll have an alias that says if anybody's looking for www.trainsignal.com, what they're actually looking for is, and I don't know the actual name, but we'll call it webserver1.trainsignal.com. And so it will redirect them to that name. And then, of course, it looks for the A record to give the IP address. Now, I will also mention one other thing real quick here, and that is specifically with the A record. That would be for IP version 4. With IP version 6, which Windows Server 2012 DNS also supports, the forward lookup record would not be known as an A record, but it would be known as a 4A or a quad A, or an AAAA record. That's the forward lookup record for IPv6. Now, another thing that I mentioned earlier is something called zone transfers. Now, I didn't call it that before. I just called it the transferring of, any updating to that information to the database out to the other servers. Well, a DNS zone transfer is something that is done with your standard primary and secondary zones. Right? The update is made on the primary. You have to transfer that information out to the secondaries. Now, this is somewhat older, not used as much anymore, and the reason why is because we don't use this with Active Directory integrated zones. And by today's standards, we should always be using Active Directory integrated zones. One of the reasons why, zone transfers can be a security risk. If somebody was to grab hold of your DNS information, right? If they were to grab hold of that DNS database and they knew the names and IP addresses and how they match up in your network, well, they could do a lot to really make things difficult on your network. So you got to keep in mind that these zone transfers can be a risk, because if you're going to transfer them, right, they're going across the network, they could be captured by maybe somebody you don't want to have capture them, and that in turn is the actual security risk. Now, if you are using zone transfers, just some terminology you should be familiar with is we have something called an AXFR, which stands for a full transfer, and this is basically like when a new DNS server comes online, it needs to get a full transfer of the database. But when changes are made, back in the old days, I should tell you, All zone transfers used to be the entire database. To help with that security risk that I was just talking about, and then also to just help make things more efficient, once the DNS servers are in place, when a change is made, only the change is transferred, and that's called an IXFR, or an incremental zone transfer. But the bottom line here is you shouldn't even really be dealing with this, and if you are, it should be minimal, because you should be working with Active Directory integrated zones and let this zone transfer information be done through Active Directory replication. So let's go take a quick look at our zones. And I know we already have some, so let's take a look and see what they look like in DNS. So back here on NYDC1, we're still in the DNS console, and you'll notice that on NYDC1, we have our forward lookup zones and our reverse lookup zones. And you'll notice that when I go to expand reverse, there aren't any. Why? Because like I said, they're typically not needed. So what do we have here? There are two different zones that are created by default. This underscore msdcs.globalmantics.local, that's what contains all of the SRV resource records that I mentioned that support Active Directory. Whereas down here we have globalmantics.local. Okay, and globalmantics.local is the zone that, and you'll notice by the way, it also, see the delegation here for MSDCS. Okay, that's what this is up here. So then that's where it would point to some of our SRV resource records if they came into globalmantics.local. But here we have some actual records, and an example would be NYDC1. It's a host or a record, and it gives the IP address for that name. Okay, so that's what our zones look like. Now if I go to the properties of this zone, you'll see here there is a name servers tab, and this is where we can see all the different name servers that have been set up, which by the way, I should tell you, this is a good example of not cleaning up after yourself. I was actually playing around and I had made my member server a DNS server for a moment, and so it's been added. So I'm going to actually remove that. And the reason is because I was using virtualization, and I did that on a member server, and then I did a snapshot. I reverted back to that snapshot, which undid it. But because I reverted back as opposed to uninstalling the service, well, this guy still thought that that was an authoritative name server for this particular namespace. That's a problem. Okay, so I'm glad that you got to see that. These are the kinds of things that can actually happen in the real world. Okay, but this is the correct information. These are the two DNS servers that are actually authoritative for globalmantics.local. Here we have a zone transfers tab, and this is where we can choose if we want to allow zone transfers or not. And now this shouldn't be checked, and again the box is checked. In other words, it wouldn't be checked by default if we were only using Active Directory integrated. But because I was playing around and with New York Mem 1, what it did was as soon as I added it as a secondary DNS server, it went ahead and said, all right, well, let's do some zone transfers. And then the choices are to any server, and that's dangerous. That means any server out there can say, hey, I'm a secondary DNS server for globalmantics.local, and I'd like you to send me your database. You see how dangerous that could be? So you don't ever want to select that. What you do want to do is either this option right here, only to servers listed on the name servers tab, which again, remember, NYMem1 was listed. That's what was all configured when I played around with that. Or you could even get more specific and say, no, you know what? I'm going to allow some zone transfers because I have maybe a secondary DNS server out there, but I'm going to tell you specifically which one, or if it's more than one, which ones I'm going to allow these zone transfers to. And anybody else that comes asking, no, they can't have the zone transfers. All right, so that's how the zones and the zone transfers work. Now there is one last piece of information here that I want to talk to you about. It is something that a lot of people won't pay a lot of attention to, again, in today's world, because things are so automated and Active Directory integrated zones just kind of, they're so good about taking care of everything. But it's the idea of managing and maintaining our DNS records. It's the idea of, being careful not to have real old, outdated records, sometimes called a stale record, sitting out there. It still happens. Even with Active Directory integrated zones, you can still have this as an issue. I know a lot of administrators will handle this manually. They'll do periodic, scavenging manually. But if you want DNS to do it for you, there is something called aging and scavenging. And aging is the idea of determining when a stale record should be removed from the DNS database. And scavenging is the idea of actually, removing that record if it is outdated or extinct from the database. Now, there's a couple of parameters involved here. There's something called the no refresh interval and the refresh interval. And the no refresh interval is something that it's a period of time where the DNS server will not even allow a record to be updated or refreshed. Because basically, once a record has been dynamically added to the database, the client that added it will periodically try to refresh and say, hey, I'm still here and you should keep this record in your database. The no refresh interval is a period of time, and it is something you can set. The default is a week. It's 7 days, but you can modify that. That's a period where I'm not even going to accept any updates. I've got the record, and I'm just going to keep the record for at least that long. And don't bother me with updating or refreshing to tell me you're still there. Once that no refresh interval period has passed, we then have the refresh interval, which is a period of time that we expect the client to come in and refresh the record. Because once we pass the no refresh and the refresh interval, that's what's considered aging. We've now aged through a period of time where we now have to determine that the record may be stale and we may want to get rid of it. So here's what it actually kind of looks like. Client comes in, says, hey, I'm here. Here's a record. Put it in your database. And we'll say that happened on June 1st. So it's time-stamped. June 1st, added this record. We have our default no refresh interval of 7 days. So basically, we will go until June 8th. That record's just going to stay there. It's not going to be updated. It's just there. Once that period has passed, there's another 7-day period, which, again, those two 7-day periods together are what's called the aging period, where we will expect the client to come in and refresh that record. If that doesn't happen by June 15th, we will then consider that record to be stale, we'll consider it to be out of date, and we will scavenge it out of the database and get it out of the system. Now, this is something that is really good to help keep your DNS database clean. Get some of those, maybe if you have, computers that come onto your network and they go ahead and send an update to the DNS server, say I'm here and here's my name, and then they disappear from the network, but yet that record just sits in your DNS database. It can get very cluttered. So that's a good thing. The bad thing is that this can be dangerous. If you don't know what you're doing and you set this, in place, you can end up having records that are needed and are still good and are not out of date. They're not extinct, and then you're going to end up deleting those records from the database. So real quick, let me just show you where and how this is done. So back here on NYDC1 in DNS, if I right click on my server, right here I have NYDC1, that's my DNS server. If I right click and I go right here and say set aging and scavenging for all zones, I can check a box. And notice it's not checked by default. Okay, so by default, Microsoft does not turn this on because it can be dangerous if you don't know what you're doing. So you check the box, and now it will use your no refresh interval and your refresh interval to go through and do what I just illustrated. The defaults are 7 days. That can be changed to a certain number of hours, okay, or a certain number of days, larger or smaller than 7, based upon your needs. Now, beyond that, there is one other quick topic point that we should talk about here. It has to do with troubleshooting DNS, right? Because we're talking about configuring and troubleshooting. Well, I will tell you this. When it comes to troubleshooting DNS, this is something that, there's nothing I can explicitly give you here that you're just automatically, boom, just going to, I'm going to fix DNS every time it goes wrong. Now, DNS is one of those real tricky ones. There's a lot to be aware of. There's a lot going on, and when things go bad, well, you might be digging for a while. Now, one of the typical places that you might look are your event logs, and you'll notice that right here we actually have DNS event logs. Hey, look, I got a bunch of warnings. I wonder what's going on. Now, similar to the event log entries that we talked about in that lesson, in the monitoring lesson, you'll see here that we typically have information. We have warnings, which means something didn't go right, but we didn't have an actual failure. It just could be leading to something. And then we have the actual nasty error ones with the red circle with the X in it, which means no, something went wrong and something did actually fail. Okay, so this is one place you can look. If you go to the actual events themselves, the actual event viewer, and look at your system log, you'll find other things that could relate to DNS but don't quite fall into the DNS events. If I go to the properties of my server, you'll see here I also have something called, I have event logging, right? And this is where I can determine what events are going to be logged, and that's for this log. But I also have debug logging, and this is where I can get real specific with the type of logging that I want to look at. This is some real advanced troubleshooting. You want to get right down to the individual types of packets and communication with the DNS server. Okay, so not anything we're going to go into great detail because, like I said, every scenario is a little bit different than the next. I mean, I can give you a perfect example of a DNS problem that we had here at Train Signal. It was actually just yesterday. And I was talking with our IT administrator, and you'll love this, right? This is Help Desk 101. I asked him if he rebooted the server. Yeah, he had been looking at a number of things, and he said, well, out of curiosity, he was trying to solve the problem, other than the typical start with a reboot, and because the service was actually stopped. Which, by the way, that's another thing you can do. You can actually go look at the services itself and see if the service is running, but things weren't running, and we weren't really sure why. And I said, well, why don't you try to reboot? Sure enough, rebooted. It whatever was stuck got fixed, and all was great with the world again. It's not always that easy, but it's a great starting point. When it comes to troubleshooting, it's a great idea to keep in mind that you want to keep it simple before you go get sophisticated with it. That's a bad habit that us IT administrators all have. We tend to overlook the obvious sometimes. We tend to want to find the sophistication in things. Sometimes you want to start out simple. Anyway, that is pretty much how DNS works. Again, the actual installation and configuration of DNS, not a whole lot to it, okay? Because in today's world, you want to be Active Directory integrated. If you're not going to do Active Directory integration, you can go in and manually go to a server and install it as a role. You could come in here, and I'll tell you what, I didn't even show you this. I could right-click on the server, and I could, do the new zone and come in here and create a new primary zone, secondary zone, stub zone. Choose to make it Active Directory integrated by storing in the Active Directory here. Okay, we could go through and do that. The recommendation is you do it by installing Active Directory domain services and then making that a DNS server as well. Oh, by the way, I just happened to notice when I clicked. Notice when I right-click on here, here's that clear cache. Remember we were talking about the cache earlier? I might as well just show you since it's right there. But anyway, that's pretty much it for DNS. There's a lot to know. Make sure you know about forwarding. Make sure you know about caching, like we were just talking about. Your zones. Make sure you know the namespace. The rest of it just kind of works in the background and makes everything function for you. So anyway, I know that was a long one, so give yourself a break. Go get a cup of coffee if you need it, and then I will see you in the next lesson.